Hello everyone. In this session, I'm going to start with the third unit. Uh, and the first topic in the third unit is the fast food problem. He started with, in the textbook, it was given with the fast food problem. Based on that, what are the weights and then how to calculate them, that was discussed. In the overall, in the third unit, we are going with let us go with the syllabus in the third unit. Here, there is the training feed forward neural networks and the fast food problem. This is we are discussing in this session, and then gradient descent. In that, we will go through the calculation of the gradient, how it is related to our problem solving, and then we will go with the back propagation, that is for updation of the weights and other concepts, and then we will go with the various types of gradient descents like the stochastic gradient descent, and then we can go with the train test sets and also the validation set, and then we can go with the overfitting. We will discuss about the overfitting problem and also how to prevent the overfitting. These concepts we will discuss as the first part of the unit 3, and the second part, it is related to the tensor flow concept. So we will discuss about the tensor flow concept in the next sessions. So first part, we are concentrating on the first part. Now in this, the fast food problem, as an example we have taken this. In the fast food area, the weights, of course it may be the fast food problem or anything. If you have some data set, if you want to handle the data set by using a model, we have to use the weights. Weights for all the connections in our neural network, they are the parameter vector. We will have the parameter vector, and in that we will maintain the weights. Okay, what are those weights? They are the supporting values for the whatever you are giving the input. Okay, so if you see this, these are the three inputs in the fast food problem example. Here, burgers, fries, and soda, these are the three inputs, and I want to estimate the total cost. Okay, with the combination of these three, you may order 3 burgers, two fries, and two sodas. Like this, you can order. So what can be the bill? You can predict. You have to predict that. So for that we can provide the input, that is x1, x2, x3. These are the three inputs, and my expected output is the y, that is the cost of the particular food order. So there will be the combination. For that, for every input we have to use some weight, that is called the W1, W2, W3, and the same weight can be represented with the different symbols. In some situations, in the mathematical way, it can be represented with the theta, and it can be represented with alpha, beta, like that. In general, in the neural networks, we will call that with W1, W2, and so on. Okay, so in this, the final output will be whatever you are giving the input, that is x1 into the weight related to that, the multiplication of the given input and the supporting weight, plus the other input and the multiplication of that other input with the corresponding weight, and so on. So we have to sum of all these, so that W1 x1 plus W2 x2 plus W3 x3, that we have to give. And this is for a single observation. Single observation means for one order. Okay, one record. We can say that one record. From the data science or from the data perspective, we can say that it is for the single record. And from the fast food problem related thing, we can say that it is single order. For one order, these are the inputs or the values that we will consider. So, and then the training. What is the training process? The training process means fixing the values for W1, W2, W3. This is the concept of training, meaning that we know the input values x1, x2, x3, and we know what is the expected y also. So we have the values of x and y values, and we have to give the input, and we have to build a model such that for the given inputs it has to generate the expected output. So to do that, we have to adjust the weights, because x1, x2, x3, they are not in our hands. It is fixed. That is the input. And y is expected. Actually, it is y and y hat. We can represent the calculated value as the y hat. In this example, they have taken as the y only. But original is the target. We can call it as the target or y. Or if you call it as the y, we can call the calculated one will be y hat. In this case, the target is t. Our target will be the original output, and whatever we are calculating by using our model, that is representing with y. So I want to give the inputs x1, x2, x3, and I am expecting some output, that is y. So to satisfy this, we have to adjust these weights. If you are able to fix the weights for W and W2, W3 values, then you can get the good results for the given x1, x2, x3 values. So the target or the goal of the machine learning algorithm is to identify the weights. Now for that, here we are giving the description for this fast food. Every single day we purchase a restaurant meal consisting of burgers, fries and sodas, and in that we want to be able to predict how much a meal is going to cost us, so that we have to identify that. Of course, if you have the cost of the burger, cost of the fry and cost of the soda for single unit, you can easily estimate. But the cashier is not giving like that. He is giving the complete bill. So complete order. So I want to estimate what is the cost for the estimate for the required meal. So I want to estimate that. How can we solve this problem? That is, we have to train a single neuron to solve this problem. We have to solve this. How can we solve this? A simple idea is there. We can order in a meal. A simple logic or simple idea to solve this problem is, we can simply order sodas in the first order. In the second order, only we can order the burger, single unit of burger. And in the next order, you can order only the single unit of the fries, so that you will get the unit price obviously, and then you can based on your requirement, you can easily calculate that by using the simple mathematical summation. So it is easy, but it is not the situation for all the cases. In most of the cases, we may not be able to do this. So this is a simple problem, so that we can order like this. But for the image processing like that, there are number of pixels, input pixels. So how can we access that? How can we give the value for the particular pixel? For each pixel we cannot give the value. So it is very difficult. So we have to find the general solution, a general way of solving this problem. That is by calculating the weights. If you are able to calculate the weights, then if you are able to estimate the weights, then you can estimate the output also. Now we can go with that. Now let us say we have the large set of training examples. For that, we have to calculate the neural network for the training example. Let us say, for example, I training example for one single example, that is one for one record. So yi equal to w1 x1 I plus I is representing the number of the record. Okay, w2 x2 plus w2 x3. And now we want to train the neuron to estimate the values of W1, W2, W3. This is our task. And if you are able to fix the W1, W2, W3 values, then the error, what is the error here? This is the calculated value by using our model. And original target is also there, that is t. So we have to compare this calculated y with the t, that is the original target. So there will be definitely there is a difference. I want to minimize that difference. If the difference is 0, then our model is perfect. If the difference is having some value, then there is some error. If the difference is very high, then our model is predicting with errors. So we have to go with the fitting of the model by estimating the values for weights. So how can we do that? Before going for the estimation, let us see how to calculate or how to evaluate the calculated output. For that we have to go for the estimation of the error. How can we estimate the weight? So see here, if we want to know, if we know that t is the original value and our calculated value, as we have seen in the previous slide, that is the concept of the calculation of the weight by using our model W1, W2, W3. And we can say that there is a difference between the y and t. So what is the y and t? See here, we can say that this is the calculated value what we have calculated by using our formula, our model, and this is the original t, original target, original cost of the meal that was given in the data set. Okay, so we have the difference, we have to find the difference between these two, and we have number of i's, meaning that number of records. For each record we have to find the t minus y, and simply if you go for the t minus y, it will give you some error, so we can find the average of that. But I don't want to go for this. I want to get the square of this error. I want to make the square of this error. Why should we square it? Because if you square some value, if the value is small, then the square will be also small. If the value is little increased, the square will be also increased. Let us say, for example, square of 1. If the error is 1, the square is also 1. If the error is 2, the square is 4. If the error is 3, if the square is 9. If the error is 4, it is increasing a lot. So that I want to evaluate the model and I want to improve the performance. For that, it is better to go for the squaring of the error. So of course, sometimes it is useful for removing the minus values, meaning that the minus will become as the positive value if you make the square. But the main thing is, it is more sensitive. If you make the square of the error, it will more sensitive. And our goal will be to select the parameter theta. Here we can observe that it is the theta. Theta means W1, W2, W3. This is the theta. Okay, the values of all the weights. And we have to select that value, and our goal is we have to make the error E as 0. So see here, we have the error function here, t minus y square, and we are making it sigma, and we are adding the 1 by 2. Actually, we can give the 1 by n or 1 by m, that is number of records. Instead of that, we are giving this 1 by 2. Why we are giving this 1 by 2? That we will give, there is a small reason behind this, why we are giving the 1 by 2. When we discuss about the gradient descent, you can understand that. I will explain at that moment. So see here, we can calculate the error by using this formula, and by using this error value, we have to set the value of W1, W2, W3. That is our goal. So if you are able to do this, if you are able to estimate the unknown weights which are satisfying with near to zero error, then our goal, we reached our goal. So this is what I want to discuss in this session. In the next session, we are going to calculate the gradients, and how to estimate the weights also we will discuss. Thank you.